Okay, this is workbook 15. I'm just going to go through it. I might even make mistakes on it, and that's what happens, and it's okay. So we're talking about segments in triangles. So one of the segments that we're going to talk about is the median. The median is, it connects one vertex to the midpoint of the opposite side. So there's a lot of talk about the opposite sides of triangles, so make sure you're paying attention to that. So vertex of one side to the median, and in fact, that right there is called the orthocenter, or the in-center. There's a name for it, but we don't have to know it. So we have the medians of a triangle connects to the midpoint. So again, here's this segment. Halfway through is the midpoint connecting with the vertex. That is called the median. Then that is the point of concurrency, where they are all the same. Like all the point of concurrency has a fancy name to it, and it's the centroid. That's what it is with a circle. So the point of concurrency is the centroid. That centroid reminds me of like a name that would be for like the Borg, if you know any references to nerdy shows. And so then you're doing stuff with those with the medians. And so we have proofs, and then I like the using. I'm going to use the using because it makes it make more sense. So in this figure shown, BD is the median of triangle ABC. If the area of CBD, I have to look at CBD is 18. What's the area of ABD? So it's going to be literally half. So that median splits the thing in half. So it's literally half. So the whole thing is going to be 36, right? So we'll just double check. ABD. Oh, no. It's half of it. So each half is the same. So there we go. And we got it right. All right. So then we come here. In this triangle, CD is the median. The area of ACD is 24. The area of BCD would also be 24. Okay, because the median splits triangle ABC, so BCD has a larger area. Nope. So they both have triangles ACD and BCD both have the median as the side of CD as a side. The median connects vertex C to the midpoint of AB. That's true. The median splits the triangle so that that has a smaller area than the triangle itself. Nope. With a larger triangle. Nope, they should be the same. Doesn't say that, does it? I don't know what 12. Oh, no, it's just the number. Okay. And then let's try the next question. Use the following information to complete the proof. Okay, so we know that AC is the same thing as AD, and AB is the median of CD. We're supposed to prove that ABC is congruent to ABD. So this triangle is congruent to that triangle. So first thing we always say is given. And then BC, so BC is congruent to BD. That's the definition of midpoint, or I guess median. AB is congruent to itself, is reflexive. And then we talked about only sides. So by side, it's the same. Submit. I'm not too sure on that number one. Let's see what I did. How I did. A partial credit. Okay. So let's see. I got 87.5. I'm going to figure out what I did. I'm going to pause it and figure out what I did. I figured out what it was. Select one answer for the area of BCD and select one answer to justify your reasoning. And I put two reasons. So the main reason why that would happen is because the median connects vertex C to the midpoint of AB. So we're talking about the area of a triangle. It's 1/2 times the base times the height. So they both have the same height. And because that's the median, they both have the same base. So I answered too many things. Even though that's true, that's not the reason why. So that's what I did. And I'm going to be okay with making a mistake on that because I went back and I learned from my mistake. And for the sake of time, I don't want to do it again. Okay, next part, 15.2. Mid-segment. So a mid-segment is when you just connect all the midpoints of all the segments. So you make that nice triangle. That's a mid-segment. That's a mid-segment triangle. Trial mid-segment theorem. If a segment is a mid-segment of the triangle, then it's parallel to the third side and the length of half the length of the third side. So what this is saying is that this length right here is literally half that length. Or this length right here is half of that length. Or this length right here is literally half of that length. And that these are parallel. Those are parallel. These are parallel. And then I don't want to prove anything. I'm just going to use it to solve a problem. It says that FE is the midsegment of triangle ABC. Okay. And so that means that this is half of that. And then GD is the midsegment of triangle AEF. So then that would be half that side. Okay. It says that CE, so CE is 4.4, BC is 6.2, the measure of angle C is 35.4. Which statement is not true? The measure of AEF, okay, so those two would be the same. AG, if that's a mixed segment, then this whole thing is 4.4, so that part is 2.2, so that is true. AE would also have to be 4.4, and DF. Let's see, if that is 6.2, then half of that is 3.1, and half of that, we want DF, right? DF is half of that, so that's not true because we wanted half of that. Okay, so I checked stuff. I didn't want to do the proof, so I didn't. Use this to complete sentences. In this triangle, AD is congruent to AB. AD is congruent to DB. So that means it's the mid-segment, I think. Let's check. And AE is congruent to EC. So good, that is a mid-segment. Then DE is 4. And DE is a mid-segment. Therefore, BC is twice that. So 2 times by 4 is 8. Good. And then next question. So use this to complete the proof. I'm just going to put given, and then I'm going to read it. So DE and DF are mid-segments of triangle APC. We're supposed to prove that angle EDF, so EDF, and angle DFB, so DFB, are congruent. So we have that. So DE is parallel to BC. That's a definition of mid-segment, triangle mid-segment. Yep, that's what I said there. And then DEF and DA are alternate interior angles. Definition of alternate interior angles. And then, so they are congruent. So alternate interior angles theorem. Not too bad. Okay, I feel pretty good about that. Assignment. Good, 100%. Okay, now the checkpoint. Ooh, the unit exam, which I'm not going to do on screen because I don't do unit exams on screen. Good luck on doing it yourself. Bye. And I'll catch you up on Unit 16.